This is you, and this is your environment. A very complex environment, made only more complicated because we live in a world that requires constant social interaction with others. According to the Machiavellian intelligence hypothesis, highly social species, such as humans and other social primates, should be intellectually superior to less social ones, because the social environment is much more complex and more challenging. The social environment is indeed complex, maybe too complex for even our large brain-to-body ratio. According to this, we should not be able to navigate the social world with anything short of mind reading. To help us out, our brain uses simple rules of thumb called heuristics to ignore part of the information in our environment and make faster decisions. Let's pretend for a moment that you're playing baseball with a friend, and he throws the ball to you and misses horribly. Predicting where and when the ball will land requires whole sets of mathematical and physics equations that you never thought would be useful in school, and it still isn't, because anyone who's ever had a childhood would know that this is definitely not happening in your head. You wouldn't even know what these equations are. The answer is simple. Keep your eyes on the ball and keep running until you eventually catch it. This heuristic can also be seen in the complex maneuvers of the dragonfly chasing after prey. Just keep the mosquito at an angle and follow it until it is eventually caught. This can also be found in bats, birds, fish, and insects. Heuristics can also be applied to our everyday social experience. Humans are social animals, and our elements of cooperation and conflict are also found in other animal societies. So our understanding of animal behavior can also be applied to humans. Social intelligence, therefore, does not require complex mental calculation. It also works with heuristics, unlike the Machiavellian intelligence hypothesis states. There are two ways social interactions play out in the world around us: direct and indirect. The same holds true for animal societies. In a flock of wading birds, a single bird flying off can also alarm its neighbors. But to avoid false alarms, checking for the predator is unreliable and takes up time. A study by Lima in 1994 suggests a simple rule of flying only if two other birds have flown at the same time. This mimicking heuristic can also be found in humans. Imagine going to a new restaurant with a few friends. If you don't have time to look over the whole menu before ordering, chances are you'll just copy the food choice of your friend. What if the whole restaurant started shouting the same food item? We all know this happens.
Shrimp fried rice, 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 totally.
Those around us can change our tendencies to buy particular items, find employment, or even commit crime. Avoiding social heuristics sounds simple. Just don't talk to anyone. But you don't even have to be around others for social heuristics to kick in. According to Emery and Clayton in 2001, scrub jays develop different strategies for hiding their food depending on the social situation. If they know another bird is watching, they would often recache their food, which is unlikely if the food is hidden in private. An example of this indirect social influence can be seen when you drive into a parking lot. In a crowded parking lot, do you take the first spot you find, or try to find a spot closer to the destination? Of course, strategies vary, but the heuristics you use here depend on the heuristics used by those who arrived before you. People you may never meet can influence your everyday decisions. Even choices that seem as personal as finding a significant other are affected. Mating choices are meant to provide good genes for future offspring. You assess qualities of health, fitness, caregiving activities, and so on. But there are plenty of fish in the sea, and you can't interview them all. A simple answer would be just do what the fish do and copy the mate choices of others. A study by Dugakin in 1996 shows that female guppies are more likely to choose males that they observe near other females, even over their own previous choices. Sound familiar? So resistance to social heuristics is futile. But what does it say for our collective decision-making as a social species? To answer that, let's take a look inside the hive mind of a honeybee. Contrary to popular belief, the queen bee is not a royal dictator demanding absolute obedience from all her subjects. The hive is therefore not governed by a central queen, but collectively by the workers, because it would be impossible to supervise thousands and thousands of workers in a colony. When a new queen is born, she takes 2/3 of the old colony, so about 10,000 bees, to find a new home. After a short pit stop, scouts are sent out to find potential nest sites. If finding an apartment with 1 or 2 roommates sounds impossible, try imagining having thousands. Luckily, the use of heuristics allows them to find their dream home without scanning every single house in the area. According to Seeley in 2003, scouts finding inferior nests advertise it less intensely and for less time through their dance. The better sites are more likely to be visited by scouts, and dancing for the inferior sites eventually dies out. The colony moves when a critical number of individuals, around 10 to 15 bees, decide on one site. Such large-scale decisions is rarely possible in human populations. The German philosopher Nietzsche said, "Madness is rare in individuals, but in groups it is the rule." In other words, a person is smart but people are stupid. And there are many examples in the real world where bad decisions are made by large groups of people. However, honeybee swarms show the reality that there are ways to achieve a high collective IQ superior to the individual. And these complicated-looking decision-making methods can be simplified into rules of thumb known as heuristics that we all share to help navigate our social world.